That means a lot. It means that if I'm late in 1 minute, you get your ice cream too late. So let's start. I would like to talk with you about just a few things we're doing in the lab. And I thought to focus on the main point that we've been interested in. And we're looking at robust autonomy by applying both lifelong learning and temporal awareness. And I'll explain to you what these things are. So in general, if you think of AI, many times we think about what we see here on the left, that you can use AI for game playing and for classification of images. And when we look at that, we many times see that AI is working beyond what human can do, which is amazing. At the same time, in other time, when we take the AI outside, it seems to many times not to be trustworthy when we take it outside of the computer, outside of its very safe and regular environment. And one of the questions is why it is. And a main feature of state-of-the-art AI is that AI is actually frozen after we program it. So if you wrote the program is there, we give it to the system, and if you see something else, too bad, we know to do what we wrote. In machine learning and neural network, we do something that is pretty similar. We give the system, let's say, a neural network, a training algorithm, maybe backpropagation, and a large data set. And then there is like a pre-time in which the system prepares itself, kind of train itself, and that's it. Now it's just like the program that we had before. From now on, this is the network, that's what we have. We'll go to the environment, it will work if it knows what to do, and it will fail if it doesn't know what to do, based on the training, the database that we gave it in advance. So when it goes to computer games, the risk is not that hard. And also we can pretty much say the rules and what can happen, but when we're going to the real world, like in self-driving cars or drones, there's actually no way to prepare for any eventuality. And actually saw that for years, the self-driving car will be ready to fully work tomorrow morning. And this tomorrow morning has been continuing now for a few years with all the promises. And the reason that they cannot get ready for everything, so they get ready for more, but there can be more malfunction. And especially if there are various agents and all of them are AI that cannot train and cannot use their experience, but only what they train in advance, then each of them can make a problem. So in general, we can think about this problem with this picture when in training time, the performance of the system gets higher, and that's it, it cannot be better. And if it receives something that it doesn't know what to do, it crashes. What we would like to do is what we call lifelong learning. And the notion is that the network has awareness of how it does. And when it sees that it's not really doing well, it doesn't predict well, its prediction and doing are not the same, then it opens up, it's aware of what happened, and it starts to improve itself. The benefit of that is that the system that is aware and can improve, it's not just about safety, it can just become expert and more and more expert, because it gets more and more experience far beyond what was trained, what was given to it perhaps in advance. So the whole notion of the lifelong learning is not to depend solely on training set, but actually to be intelligent. So I was in DARPA for some years, and we had this program, lifelong learning, there. So the main work that I'm doing started there, first as a program manager, now back as a professor. And for the lifelong learning, it has a few features that without them, we think the system will not work well. One is this notion of continual learning. That is what I mentioned, that we can expand our knowledge with time. The second one is that the system has to have internal explorations, that it cannot only be relying on output that is coming from the outside, but it has to be just like us. We dream about things, we think about things, we do all kind of unconscious play, and we get our juices going, so we can learn better how to compare us to others, us to the environment. We can see what options we have to behave. So this is the internal exploration that any intelligent system really must have, or it will be only doing things that it was given, and that's bad. The next one is context modulated computation. So let's say we learn to drive a car and bicycle and something else. And now there is another thing on wheels. And I want to use the previous knowledge to already ease me into that. I want to modulate information that I have to a different context so that I can get in a better way in. And the last thing is that we really want to get from all that new capabilities, new models, or else all this learning and internal exploration and modulation are really not worth anything if we cannot do something that is really good with them. Okay, so I'll show you just a little bit examples of what we can do. So this is on the right, it really shows you what's the main problem of continual learning, which is called catastrophic forgetting. And the notion is, let's say that we learned one task, which was to separate zeros and ones. So the network knows to do it very well. Now I'm taking the same network and I want to teach it another class, which is another task, which is to separate 2s from 3s. Okay, so I'm learning the 2s from 3s. I'm giving it to the network, and that's what the network is doing. What we see here on the right, it does 2s and 3s, and it forgot the 0 and 1. The reason is that it put its knowledge on the same weights, on the same information. So various ideas came in the literature from 2017, 1919, and they suggested all kinds of methods that if you use them, you can add, let's say, 5 tasks and still remember them. And if you don't use them, you'll forget them. And they're very proud of themselves, especially it started with the Google DeepMind that I heard the talk that they thought that they solved the field. However, there is a really serious problem with all of them, and this is the following. Let's say that you have this task, but you don't want to be a robot, you want to be more like a human. That is, if I learned to separate 6 from 7 and 2 from 3, I want also to be able to separate now 2 from 6. So it's not a task, but it's a combination of classes. So we call it class incremental learning. If you use all the methods that were used before, they will all fail and are totally unable to do this combination. In fact, they're doing worse than if you were not doing any algorithm. They kind of force the system to remember exactly this task and don't allow to anything. So some methods are kind of have to come, which will work and will be able to do class incremental learning. This is like the 001 in continual learning. It's like first step for lifelong learning. So we had some suggestion how to do that, and I'll show it to you very generally. In general, let's say we learned 0 1s, and then we want to learn 2 to 3. So one way that we could have is to keep the previous examples, so that when I train on the 2 to 3, I will also bring in some of the previous things. It's kind of like training from the beginning in a way. So we need to store the previous one and retrain the network with everything. You can figure out that this is not the way biology brought, and this is not a very good or scalable way. Another option is, instead of keeping information before, we can generate information from before. So if this is the network that will be learning now 2s and 3s, you would want the network to be able to bring us examples of 0 against 1, even just from the model, even that we didn't remember the details. This is a little bit like dreams, you know, we generate and then replay and then we organize our network, which is nice idea, but there are lots of practical issues with that. Both biologically and in AI, generators work very badly. So from whatever you know about GANs and generators, it's always lack what you see in applications. So the thing that worked for us really well is the brain-like abstraction and replay, and the idea that there is one network. We don't generate all the way to the input, but generate only to high abstraction, just a little bit. So it means that we get all kind of information that is really unclear for the eye because it's already abstraction, but we only generalize to high level of abstraction and do the relearning here. So it's very fast and it works and it saves us. So I'm looking at the time, and I want to say that internal exploration is what we say that is very important. You have like a way, the shaded arm is the way that the arm tries to figure out how it works. And if it can figure out more or less, it doesn't have to be perfect, Then if we change the arm a little bit, it will still work. So we'll not need to learn from the beginning, which is really great. There are all kinds of other models that people suggested in lifelong learning that combine engineering system together with biological cells. And in fact, there's some small robots that are being worked on as we talk in a few labs. That are very interesting other concepts. And I think the important thing to remember for lifelong learning is that it's not in order to find cats and separate them from horses. It's about behaving in an environment that can change, behaving in a time that things can work, which means that if you don't have, if you're not Facebook and you don't have billion examples, you only have 200 examples, start there and become more expert as you go. So if you want to think, for example, about having a StarCraft 2, we can think about an agent that starts working. And as it's working, the system can start changing the terrains. Maybe it will alter unit capability. Maybe it will go all the way to switch friends and foes. So we have to be aware, maybe move goals, maybe increase weapon range, and it doesn't tell us what it will do. So we cannot kind of prepare in advance. And that the whole notion of lifelong learning, to be there and to work when you don't have things in advance. So I will not talk to you about temporal learning, but just to say that if we have system with reflexes, this system can protect us also from the unknown. And hence when we find also temporal features and reflexes and other features like this, we can get very strong methods. So that's it. So what my lab is trying to do is really work on all kind of methods that bring AI to become better, solve problems that were not solved, and take ideas from everywhere that is available for us. And it's typically from biology, because that's where the best ideas usually are found. That's it. I finished just on time, even though I started late. So thank you very much. And I'm here if you have any questions, please email me. It's just hava@umass.edu. I see that there is a question here. Is it a question or is it claps? Claps. Thank you very much. Okay. Taylor, all yours.
All right, well, thank you so much, Hava. This is, of course, our last faculty highlight of the day. So there are a couple of faculty members just kind of milling around in the candidate faculty meeting room, but otherwise you all are free to go. Thank you all for your attendance, and feel free to contact me with any questions. I'll be sending around.
Taylor, I have a question. If people have questions, can they still talk to me here for a few minutes?
Oh yeah, for sure. I'll leave it open.
Okay, great. So I'll stay here for a few minutes, and anybody who wants to stay and discuss.
Yeah, stay as long as you want. We'll just keep it open.
Perfect. Thank you.
Thank you, Hava.
I see Ben, you here.
Hello. Yeah.
Perfect. And anybody has any question or anything, or you want to tell me about how was your day, the candidate week, and you have any question about this talk, about other people's work? Hey, Chelsea.
Hey, I was going to say, you could tell everyone's been on Zoom since 9 a.m. this morning because they're all very quiet.
Okay. I was so bad with finding myself with this little robot, jumping robot. It's really not for me.
I got stuck at one point. I wasn't sure how to get through. I was like, oh, I guess I'm just going to hang out here for a little bit, guys.
I walked to a help desk to ask him how to get from the screen. Yeah, good. Any advances on your side?
Oh, for Lincoln Scholars?
Yeah.
No, Tuesday, March 9th, I put in everything, and then I have to do one presentation, but so far there's only well, one other girl applying, but she's only doing the master's. So it looks like at this point I'm kind of the only one.
Okay, perfect. Okay,
So not
I
a
wish
bad
everything
spot to
could
be
go
in, I
smoothly.
guess.
Perfect, wonderful. And then, so you figure out if Sunday will be good for you. You know, you don't live that close. Are you going to fly or to drive if you come to visit us?
So my brother's in Boston, which is a little ways away. But I was planning to drive and maybe, yeah. And if Sunday is not like a good time, I can also just stop by I think the lab and like hang out with some of the students there. Like, they're really welcoming. So
Okay, yeah, yeah. I mean, the students are great. I don't know who you met already, but the lab is really friendly and people work together really. I can tell you that two of my students are, are not here because they worked all night on different projects. Each of them worked on there. I just heard from one of them in the morning that both of them worked all night, but these are the night owls. But, it's nice. People can discuss with each other their projects. We have lots of common projects. I mean, we just submitted a paper with 3 grad students working together on that. So, yeah, I think you'll enjoy, just visit. And what I can do is so the following Sunday, the 20, can work for me, but if you come in another day, maybe I'll leave them something that they can take you for nice lunch in some of the most fun restaurants. So I'll approve it in advance, so you can have a little party.
yeah. And also, you mentioned you were going to Europe. Was that for the cosine conference or is that for something else?
No, this is something else.
Okay.
Yeah,
Yeah, it sounds
giving a
exciting.
talk in some very exotic places. I'll tell you when I'm back.
Very cool.
Yeah, when is the cosine? Is it also that week?
Like a little bit, like starting the 17th to the 22nd, like
Okay.
around that time. But
Yeah, just a little later. Where is it this year?
I think it's in Portugal. I know some people can't make it though because of like visa issues, so it's kind of a bummer for like there's yeah, but so they're doing it in person.
Yeah, I haven't been there in years. When I used to go there, it was every year in the States. Yeah. So what are you working on, Ben?
So right now I'm kind of just doing like there's this thesis for seniors and I'm trying to finish that up. But also this summer, I think I'll be interning again with the Air Force. We haven't discussed this year's project in detail, but something continuing work with like neural networks. Yeah.
Okay, that's good. And where will you be located?
It's in Florida, but they do have the option to do it remotely. I have to actually get that sorted out. So
Good luck. It sounds fun.
thanks. Yeah, so I
Very
think
Did you say
good.
Florida in the summer?
yeah, Florida in the summer. So
Yeah.
it would be a spectacle.
I was gonna say remote might be not the worst option. That's very
Yeah.
unless you like the warm weather.
Or I'm very used to like New England East Coast weather actually. I don't know if I would fare that well.
Yeah. Yeah, I see Chloe. Are you here?
Yeah, I am. Hi.
Good. How was your day? Are you dead?
Yeah, it's been really fun so far, though I am reaching like my late afternoon slump slash being on Zoom for so long.
Yeah.
Yeah.
Yeah, it's true. Impossible. And I see we have somebody here, Negin Rahimi. Are you here or you just forgot to close yourself? You know how sometimes when everything is ending, like sometimes we have committee meetings and you see a person there, he's quiet all the time, and then the meeting is closed and the person is still there, and you kind of figure out that, it's a good trick,
Right. One time, I left a class, like an online class, like for a few minutes to like grab some water. The professor like ended the class early, and so I came back, and they're like, "Do you have a question? Hello?" And I'm like, "I'm so sorry."
Yeah, this is so human. None of us is actually glued to the chair. Even if it was a regular day, we'll even less. I mean, we'll move from class to class. We'll take advance. So it's a reality.
Yeah.
Yeah, that's perfect. Ben, are you going to other universities to check, or you pretty much set on us?
So there's one in New York, and I am waiting on a couple decisions. So kind of nerve-wracking, but so far I'm making it through.
So New York means that it will be much cheaper for you? Oh, actually, grad school doesn't mean much. I mean, anyway, on a fellowship.
So I mean, housing in New York is a bit expensive.
Oh, you're
But
right.
overall, like I'm looking to like figure out like there's a balance. Like there's a thing I'm doing that like I'm trying to save some finances for the future, etc.
Yeah. Yeah, at least in the sciences and engineering, you paid for your grad school. So at least it's not becoming negative. I have a friend who just finished master's in nursing, and it's $200,000 for 2 years. Well, she went to private school, but this is crazy.
Yeah, the other school I got accepted into is BU, and their stipend isn't that much more than UMass's, which is crazy because you have to live in Boston and it's much cheaper to live out in Amherst. So I was just hearing some of the students going, that's all we get. I'm like, good luck.
Right. For a while, I wasn't even considering grad school just because I thought that like I'd have to put more money into it. So I was like, oh, I should probably like go into industry and like start making money. But when I found out that like I don't actually have to pay, I was like, that's nice.
Yeah.
Yeah.
I mean, you don't make enough if you took loans for your bachelor. I mean, you can live, but I don't think you have enough to return.
Right. But I think I've looked into it and it's like there's like ways to like hold off having to make the payments. So
yeah,
I'll figure it out.
Also in the summer, there are ways to make much more money for the summers.
Right.
So, my son is in grad school in Johns Hopkins, and they're really cheap. They give such little money. Yeah, you can't really live on that.
Right.
Like in Baltimore, like around there, or
Yeah.
that's
Also, the
pretty
area
expensive.
is disgusting. I mean, it's really scary, just to walk. You just walk for, I mean, you know how on the map you can see where people were mugged and what kind of, they show you like in the last month, there were like 5 times, threats with gun and this and that and this. And it's like, it's all so close to my son's little place and just between him and the university. And yeah.
Do you like call them all the time and you're like, are you okay? Don't walk at night, please.
Exactly.
Yeah, definitely not.
Exactly. Yeah, it's really scary.
I like that when I was to UMass when they were saying that a lot of students were doing summer internships and stuff. And I was like, oh, it's really good that they do summer internships in industry.
Yeah, it's a good thing. For my students last year, I think everybody stayed, but it was a decision that, kind of all the new students wanted to stay. I think many times new students stay for the first 1 or 2 summers so that they can advance a lot. And then it's kind of moving nicely. And when it's moving nicely, you can take the time off to industry and you still feel good and come back with new ideas. It's different if you're not yet settled in your research and you're stressed about it.
Right.
And then you also have to take time off. So I think many times people take the 1-2 first summers. By the way, just to tell you about Amherst, I'm leaving my car unlocked and my home unlocked.
Oh.
So yeah. Like now I'm going abroad and I'm leaving it even then unlocked because I'm going to have some visitors that will use my home when I'm away. So it does feel safe. I hope I'm not crazy, but I've done it for the last 20 years and so far it worked.
Cool.
Yeah. No, so you don't have to do exactly that, but it feels very safe.
Right.
Yeah. Okay, people. I hope everything is good. I hope you'll find the place you want, and I hope it will be UMass.
Thank
Thank
you,
you.
Hava. Have a wonderful
Thank you so
weekend.
much.
Yeah,
Bye-bye.
take care.
Nice meeting you all. Bye.